Now in this video we are going to derive the Gauss's law of magnetostatics. Like first equation we have to derive the second equation, and that is del dot B equal to 0, known as the Maxwell's second equation. Now student, take this as a surface. This is a surface wherein that electric flux is passing through it. So this diagram shows this way the electric flux is entering and this way the flux is coming out. Okay, here you can imagine this surface is kept in a magnetic field and we are looking at this. What is the divergence of magnetic field actually here? So this is very important and very interesting law which tells us that magnetic monopole does not exist. यानी जो कोई भी मैग्नेट है आपका, आप उसको हमेशा डाइपोल में पाओगे, यानी नॉर्थ एंड साउथ पोल में पाओगे. इवन इफ यू ब्रेक इट इन स्मॉल पार्ट्स, it will give you north and south poles again and again. If you break it continuously and you make it smaller and smaller, even you reach to atomic level, there only you will find the no monopole, means always dipoles. So this equation is also referred as del dot B equals to 0. It tells us that magnetic monopole does not exist. So very interesting law. So this now look, what is the statement of this? Very simple. The number of lines emerging from any volume bounded by by a closed surface S. The number of lines emerging from any volume bounded by a closed surface S is always equal to the number of lines entering the volume. जितनी लाइन्स आ रही है उतनी लाइन बाहर को जा रही है. तो अब हमको यहाँ पे मैथमेटिकली ये देखना है कि उसे कैसे लिखा जाता है. तो इसका मतलब ये होता है कि यहाँ पे फ्लक्स ऑफ मैग्नेटिक फील्ड थ्रू एनी क्लोज सरफेस इज इक्वल्स टू 0. यहाँ पर खुद ये फ्लक्स जनरेट नहीं कर रहा है सरफेस. इसके लिए इस सरफेस पे जो सरफेस इंटीग्रल लेंगे, क्लोज सरफेस इंटीग्रल अगर इस सरफेस पे मैग्नेटिक फ्लक्स का लेंगे तो हम उसको लिखेंगे क्लोज सरफेस इंटीग्रल ऑफ B इंटू डी एस इज इक्वल्स टू 0. This equation number 1 can also be referred as the Maxwell's second equation in integral form according to the statement, according to the law. But as we are interested in going in derivation of the point form, that is the differential form of Maxwell's equations, so we will now try to move on del dot B equal to 0, that is the point form or differential form. So this equation number 1, closed surface integral B dot ds is equal to 0. Now using divergence theorem. डाइवर्जेंस थ्योरम में क्या देखा था हमने कि कोई जो वेक्टर है डेल डॉट बी, अगर हमने बी वेक्टर लिया तो डाइवर्जेंस वॉल्यूम इंटीग्रल ऑफ डाइवर्जेंस ऑफ बी ओवर द वॉल्यूम इज इक्वल्स टू द क्लोज सरफेस इंटीग्रेशन ऑफ द सेम वेक्टर. सो हमारे पास में लेफ्ट हैंड साइड में इक्वेशन नंबर 1 and 2 आर सेम, सो वी कैन राइट 1 इज सेम एज ऑफ सेकेंड. ओके, सो दिस closed surface integration B dot ds is equals to 0. So we say that equation number 1 is 0 and that is equals to this. So this portion, this expression, right hand side expression must be equal to 0. Therefore we write volume integral of divergence of magnetic field vector is equals to 0. Okay, as this integration over the volume is 0, that means this part del dot B, divergence of magnetic field, must be equal to 0. Therefore del dot B is equals to 0, and this is the third equation. This is the second equation of Maxwell and known as a Gauss's law of magnetostatics.